So we'll start with this question of what do we know? And this is true in Florida and in the southeastern United States, and it's true in much of Brazil. We know that weaning is the most stressful event that a calf will ever have in its life. And that's the permanent separation from its mother. Now, in many parts of the United States, that's also associated with transportation. So these calves were weaned that morning, and they're loaded into this truck and then shipped all the way to Texas. And that's not uncommon. And so that one day, that calf goes through its most stressful day of its life. And we want to make sure that this calf is mineral adequate. But we know that stress results in a loss of minerals. So as animals become stressed, they liberate minerals from their tissues to go into the bloodstream. It's filtered through the kidney and excreted in urine, or through bile and excreted in feces. We know that's true. And then we also know that calves often have inadequate trace mineral status at weaning. I'm going to talk to you about that and why that is the case. And so trace mineral status is linked to post-weaning performance. Number one area that it's linked to is health, right? We know that we have to have adequate trace minerals in calves for them to respond to vaccination. And this is well established in the literature. We also know that if calves have inadequate mineral at weaning and they're managed properly, and you get them to eat well in the receiving yard right after they're weaned, they will replenish their minerals quickly. We know that that works. But what happens if you can't get the mineral in the calves after weaning? They go through a stress, they don't respond to vaccine, and then you have a disease outbreak. And many of these disease outbreaks are shown in these weaned calves to be associated with low mineral status. Now, we also know this. Calves are almost always born with adequate trace minerals in their tissues. You can take a cow and make her extremely mineral deficient, a pregnant cow, in copper, zinc, manganese, and she will give birth to a calf that has adequate mineral status. She'll take everything she has from her body to make sure that this calf has adequate status. But we also know that this declines over time. And the big reason is that calves have poor intake of mineral, the free choice mineral, they just don't eat a lot of it, and they have losses due to stress. So what can we do to improve this? That's been the general focus, the general question that we've asked. So in Brazil and the United States, the trace minerals that are the most commonly deficient are zinc, selenium, and copper. So much of this story is going to be about those three. Around the world, selenium is the most deficient trace mineral in grazing systems, by far more deficient than any other. Now, I know there's areas of Brazil that has high selenium in their soils, and those plants are not deficient. We have those areas in the United States as well. But if you took the entire grazing system of the world, it would be selenium. So I'm going to focus on that a little bit as we go. Well, here's an example. These calves are born to well-managed calves, and they have adequate selenium status. But then over time, even with access to a well-formulated mineral supplement, over time it decreases. And these are healthy calves. Now when we're weaning them here at age 250, approximately 250, they're inadequate in selenium. Now this only matters if there's a disease outbreak or some problem that would occur. From this day of weaning on, it'll even go down further because of the stress associated with weaning. So this is something that we know, and it happens all over the world. And it's a focus for how we could do a better job. So our idea has been to work with what we call limit feed creep. And that's an important translation. I don't know if that comes across that clear. But I wish 15 years ago, Juliana, I wish we would have named this something different. Because in the United States, creep feeding has such a negative connotation. People think of it negatively because the cost of gain for unlimited creep is generally the most expensive of any stage of the production cycle. So when producers hear me talk about creep, they just stop listening. But the idea was different. The idea was that we would take supplements to the calves in a grazing or cow exclusion area, an area where we could feed the calves that the cows couldn't get to. And we would feed a small amount, about 250 grams a day. It's very concentrated in minerals. And then we would do some different things. It would give them exposure to concentrated feed. It would give them human-feed interaction, but it would also deliver the mineral. That was the goal. And we called it limit-fed mineral. So here's a slide I show quite a bit. Here's what happens. We used all sulfate forms of copper, zinc, and manganese. And this is the creep feed, limit creep with mineral. I'm sorry, without mineral, without. And this is the creep feed with mineral. And our goal, remember, was to get 250 grams. So after about 6 to 8 weeks, look, they're eating it. But if you have mineral in it, they won't eat it at all. There's nothing wrong with this feed. What the amount that they don't eat, we take and give to the cull cows or to the bull battery, and they eat it readily. But calves have, I don't know the exact number, but it's 20 to 30 times, a calf that's 12 months or less, 20 to 30 times the taste buds on their tongue that a mature cow has. They're very, very sensitive. And so we would watch these calves eat this, and they would eat it in their mouth, and you could just tell they had a bad reaction. Now imagine, have you ever had copper sulfate on your tongue before? You know what this is like? I mean, or foil. Does the foil translate right, Juliana? The foil, like on a sandwich, and it gets on your teeth, and you have that terrible taste. It's this metallic taste that we think is the problem. And so we tried everything. A lot of different, formulations and palatability enhancers. Even dehydrated alfalfa meal, which is highly palatable, to try to get these calves to eat, and we didn't have any luck. So we ended up building this system here that was really modeled after what we learned in Brazil, where the cows can consume mineral at one area, and the calves can consume a different formulation in another area, and then we could measure how much each of them were consuming. So let me tell you a little bit about the forms of mineral that we were using. Sulfates and oxides are the most common. They're generally highly soluble. We also looked at organic trace minerals. And you all know about organic trace minerals. It's the inorganic metal attached to some organic ligand. And there's all kinds of them out there. We know that in monogastrics, there's a lot of evidence that they have increased bioavailability. There's less evidence in ruminants in certain areas. The hydroxy minerals at the time were kind of new. They are crystalline inorganic minerals. They have a very good flow rate, if you've ever seen it before, so they're easy to mix in these different supplements that we were working with. And what it is it's a hydroxy covalent bond, so the metal is covalently bound to a hydroxy group. So they're characterized as being generally more concentrated, and so they fit easier into the premix formula, at least for what we were doing, and they generally are characterized as being poorly soluble or low solubility. So our hypothesis was that if we could replace the copper, zinc, and manganese from a source of mineral that would not dissolve in their mouth, that it would take away that palatability problem and hopefully solve our intake. Now, at the time, I had tried many different things to make this work. And this was not my idea. This was somebody from the original micronutrients group. His name is Steve Cohen. And he said, John, I think that this will work. I said, well, maybe it'll work a little bit, but it's not going to solve the problem. So we ran this study and decided to do what we call a preferential intake. Preference intake. So we gave calves, early wean calves about the same age, we gave them access to concentrated, mineral concentrated feeds that were formulated from, do I have it up here, that were formulated from organic trace minerals, sulfate trace minerals, or hydroxy trace minerals. But look at how concentrated they are. See, this is like a salt-based mineral supplement, but this is a creep feed. This is a concentrate-based supplement, but very high in trace mineral concentration. Okay, and then I'll show you how we ran this study in the next slide. So these calves are about 150 days old, and they've been weaned. So they're consuming a total mixed ration and a dry lot. And then here are their tubs. So this would have each of the 3 treatments, the exact same formulation, no difference. The only difference was the source of mineral to achieve that. And then we would take away their basal feed for a number of hours so they'd have a little bit of hunger, and then we would provide these for them. And then we'd give them a period of time to eat, and we would just measure what they ate. How much did they eat of each? Very simple. So this was 4 different experiments using the same model that I just showed to you before. Very easy. So the first one was just simply copper, right? Nothing else was different, just source of copper, either organic copper, hydroxy copper, or sulfate copper. And then the next experiment was zinc. And the next experiment was manganese. And then we ran it with all 3 together, being swapped out. And what you'll find is in every case, the calves preferred to consume the supplement with the hydroxychloride mineral in it. We believe because it didn't have that poor palatability. Now, we have some evidence that supports that in the next study. But when we ran it where we replaced all 3, those calves exclusively would consume, given a choice, would exclusively consume the supplement with the hydroxy trace minerals. It was quite interesting. So we moved out then to those feeders that I was telling you about, the mineral feeding system that we copied from the ones here in Brazil. And we looked at the same study, but using it in a salt-based mineral. Not in a concentrate, but a salt-based mineral. So that's what we did here. So there were 4 pastures, 18 cow-calf pairs per pasture. And in this case, we replaced all the copper, zinc, and manganese in one option from hydroxy, one from sulfate, and one from organic. Now you can see again, they're very concentrated. But this is a salt-based mineral, right? It's not a concentrate supplement, salt-based mineral. 2,500, 5,000, and 4,000 for copper, zinc, and manganese in milligrams per kilogram. And then we just looked at the preferential intake over 18 weeks. Now, these are stainless steel tubs, and the bottom of the tubs, we drilled holes in there. So if water got in there, the water would drain out, and it wouldn't, it wouldn't just pool in the tubs. So again, those 3 treatments here, the calves could eat whatever they wanted. We saw the same response that when the copper, zinc, and manganese is delivered by the hydroxy forms of metals, they have this preferential intake. They consume more of that option. If you add all of these up, that's 100. That's 100% of the disappearance, with the majority of it coming from this treatment. But there's day-to-day variation, and that's what I wanted to show you here. This doesn't mean a whole lot, but it helps me tell you a story that really turned out to give us some evidence on the solubility of the sulfate and organic. So this is 18 weeks. Now look what happens. When those calves start eating, this is exactly what we expected. After a short period of time, they start preferring to consume the mineral from the hydroxy chloride. This is exactly what we expected. If you add these up, 1, 2, 3, that's 100%. So 55% from the hydroxychloride and then from the other 2. But look now, the preferential intake went down. Why? They were already eating it, and there was no problem. Now it went down. Then it goes back up again, and then back down, then back up again. This makes no sense because they're starting to learn they ought to continue to eat the way they were. So there was a young lady named Luana Carmelak that was doing some work with us at the research center. And she was what we call a sandwich program, where she was doing her degree in Brazil, but was spending a year with us to do some research experience. And her English was as good as my Portuguese. So I showed her, I said, Luana, what is wrong here? Why is this coming down? This doesn't make any sense. She says, I don't know, but she tried to explain to me, but I couldn't understand what she was saying. So we have plenty of Brazilian students. So I had a Brazilian student come in that was doing a PhD at the time. I said, Felipe, listen to Luana. Tell me what she's trying to say. So this happens to me in Brazil all the time. A very long conversation, and then the answer is something very short. And I know that there's a lot more that was said. So she tells the story, and then he looks at me and says, it's because of the rain. And what happened was, when those minerals would get soaked with rain, it would leach out the metal, and now the taste was gone. So that didn't matter. They would eat any of them because the metal was gone, so the offensive taste was gone. So on the dry weeks, they eat a lot. On the wet weeks, they eat less. And so we thought, wow, in Florida in the summertime, it's much like many areas of Brazil. We get a lot of rain, and the rain can come down this way or this way or this way, right? So you can have a really good mineral feeder, but you can still get the mineral wet. So we moved into this study here, and this is my last couple of slides, where we simply wanted to look at how could we model, we call it leaching loss. And I don't know if the word leaching translates well, but it's the loss from the wetness from the rain that leaches away the metal. How could we measure this leaching loss, in the lab, and something simple and that we could repeat? So that's what we did. So we replicated for us what would be about 4 inches of rain, or 10.2 centimeters, in 1 week. But it wasn't all at once. That's a lot of rain. So we would do it on Monday, Wednesday, and Friday. So it'd be like a really rainy week. It would be like these weeks in here. And then we looked at how much metal was lost. So here's an example. We'd put the minerals in here, and just simply we would pH adjust the water so it'd be like rainwater, and just treat them. And then we would collect the leachates here, and then measure how much was lost. Very simple. And then look what happens. So with a 10.2 centimeter rainfall, we're losing about 80% of the zinc sulfate, of the zinc from zinc sulfate. About the same from organic zinc, but only 20% from the hydroxy. Same way on the manganese. We're losing 60%. I'm sorry, not 80, that's 60. We're losing about 60% here and about 10% or less on the hydroxy. So it's a lot of loss. If that mineral gets wet, what you think the cows are eating and what they're actually eating can be very, very different. And I think that this has a really important application in tropical and subtropical environments that deal with a lot of water. Now, I wanted to show you this last slide because this is, remember I told you we delivered the treatments on Monday, Wednesday, and Friday? Well, that was 10.3 divided by 3, so 3 point something. Well, the first event 1, is right here. So a third of that rain, just 1/3 of that, caused most of the zinc loss. Remember, it was 80% of the total, and over 2/3, over 75%, came from just that third, and smaller amounts for the other 2. So usually when I show these data, people ask me, well, were the minerals protected using ingredients like vegetable oil or other types of sustaining weatherizing. That word probably doesn't translate, does it? Weatherizing. And they were not. And so we started in our lab taking in commercial minerals from other companies, and we would test it for them confidentially and share with them the results that we were getting. And we definitely see a reduction in the mineral loss if these weathering agents are used. But it's just a reduction in the overall loss. The separation of treatments continues to be the same. The last thing I want to tell you is all of these were done with sulfate forms here, or organic forms. And Terry Ingles, a good friend of mine, and he and I talk about that with his solubility. In the United States, there's a lot of zinc that's fed as zinc oxide, high quality zinc oxide. It's much less soluble than zinc sulfate. And almost all, or not all, but a lot of the manganese fed is fed as manganese oxide, which is much less soluble than manganese sulfate. But copper is different. Copper sulfate is by far the most common if you think of the sulfate forms or inorganic forms. Yeah. So that was the last slide that I had, and if you have any questions on this, I'd be happy to try to address them. You think of something we missed, Juliana? The calves that we've also, Juliana and I have also done studies where we've looked at the mineral status of calves that are fed these products, and they are able to have greater selenium status at weaning. And it's interesting because the whole hydroxy mineral story, they don't sell selenium. But it's because of hydroxy copper, zinc, and manganese that we've been able to improve the selenium status of our calves, because the calves eat more mineral. And our problem is selenium. So we need them to eat more, and by increasing the palatability of the product, it's been useful for us.